Okay, so now for the other kind of shifting, or not shifting, well, it is a shifting, but the other kind of shifting that could happen other than vertical shifting, and this is kind of like one of the final transformations that we could do to a sine or cosine is horizontal shifting, okay? So this looks like the following. So we have f of t is equal to some, let's say, sine, or this could be cosine as well. It works the same way. Okay, so we have some b, and that remember that gave us our horizontal stretch or compress, stretch or compression. Okay, and then we have t, and then minus an h. Okay, so this is really important, this form here, because sometimes you usually see something like this, sine of 2t minus 3, let's say, and then you'll say, oh, okay, our h is 3. But no, that's not the case. H is not equal to 3. What we would have to do first is actually factor out the b, okay, so in this case our 2. We have to factor out the b, so we have b times t minus h, okay? So for this case, we would have to do sine of, factor out the 2, so we get t minus 3 over 2, okay? See how we factored that out? And you can always check by redistributing it in the 2. But anyways, so our h in this case would be actually 3 over 2. Okay, so that's just really important. That's a crucial kind of like subtlety that you don't want to miss. Okay, so we just factor out that b first, and then you'll see your h right there. Okay, so h tells you how much you move, how much your graph moves. We could say shifts, to be formal about this. Shifts left or right, okay? So, for our mini example over here, because we got h is equal to positive 3 over 2, and that negative sign, that just means kind of opposite. You know how horizontal shifting is a little bit opposite than normal, than you would think. But anyways, our h is equal to positive 3 over 2, so that means all of our points would be shifted right. So we shift to the right by 3 over 2 units. We just shift all of our points over, okay? So here is the general form for transforming sine and cosine. Transforming sine and cosine graphs. Okay, so here it is. We're going to have f of, and I'll just use t's. F of t is equal to a, we're just going to put it all together, sine of b times t minus h, and then plus a k. And it works exactly the same for cosine as well. The same transformations hold. So a times cosine, we just switch that in there, b times t minus h, and then plus k. Alrighty, and just a refresher, a gives us our amplitude. Amplitude. That means the largest magnitude or the largest distance that we move away from our midline. Okay. B tells you your horizontal stretching or compressing. I'll just call it scaling. Okay. Horizontal scaling. Okay. Our H tells us our horizontal shifting. Horizontal shifting, left or right. Okay. And our K tells us vertical shifting. Vertical shifting. And that would be up or down, of course. Alrighty, so now let's try an example of this. Alrighty, so this question tells us to sketch a graph of f of t is equal to 3 times sine of pi over 4t minus pi over 4. Okay, so let's break this down. So first of all, what I'm going to do is factor out that b sitting in front of the t, okay? So if we have 3 times sine of pi over 4, and I'm going to write a parentheses, t minus something, and that would have to be a 1, right, if you factor the pi over 4 out, okay? And then we can kind of just write in a plus 0, okay? So that tells us, first of all, let's label some things. So k is equal to 0, k equals 0, which means that our midline formula, the equation for our horizontal line about which our sine function oscillates, is going to be y equals k, so that'll be y equals 0, okay? 3 out in front here, that's the coefficient to our sine, so that's going to give us the amplitude, so that means we'll be going up and down 3 from oscillating from this y equals 0 midline, okay? Let me just label that as our midline so we know what's going on here. Alrighty, our b b is equal to pi over 4, which will tell us how much we can stretch or compress in the horizontal direction, which means that our period is going to change. And our period, our new period, is given by the formula, at least for sines and cosines, 2 pi over b. Okay, so if we plug that into the formula, we get 2 pi over 4. And when you divide by a fraction, you just multiply by its reciprocal. So we have 2 pi times 4 over pi. Okay, so the pi's cancel out, and we just get t new is equal to 8. So this is our new period. Okay, that's what the b tells us. And finally, we have h is equal to 1. So that means we'll be shifting to the right by 1 unit. So to the right by 1 unit. So let's put this together on the next slide. So we have our amplitude is 3. Our b is equal to pi over 4, but that's not really the important part. It's that led us to realize that our new period is going to be 8, which that's kind of funny, right? It doesn't have any pi's in it. We'll see what that leads us to. H is equal to a positive 1, which means we're going to move to the right 1. And our midline is equal to, is y equals 0. Okay? So let's start graphing this thing. So let's say we have something like this. We have our t-axis and our f of t. Okay? And then let me just write a refresher. So f of t is equal to 3 times sine of pi over 4 t minus pi over 4. So that's the equation we started with. That's how we got all of this information on the top row there. Okay, so let me just label some things. So we're actually going to see, okay, so we need this. So this t is equal to 8, so we need actually in numbers, like normal numbers, not pi or anything. So let me count here. 2, 4, 6, 8, 9, just kidding, 9, and 10. Okay, so you have something like this. That's a little bit strange, right? Here's -1, -2, etc., etc. Let's label up to positive 3, okay, and -3 in the y direction. Okay, so what's going on here? So we have to shift, first of all. We have a sine graph. So that means we're going to be starting at 0, going up, coming down, and then going back to 0. Right? We cross 0 3 times. So that's what one cycle looks like. We're going to have this same shape being repeated, and now this shape is just going to be stretched, compressed, and shifted around. Okay? So the first thing is, normally this point here is 0, 0. But instead, because we have this horizontal shifting, we have to shift everything to the right 1. Okay, so that 0, 0 is now going to move to 1, 0. Okay, so our cycle is going to start here. Alrighty? And we know that t equals 8, so that means that it's going to end. So the distance between the start and the end is going to be 8 units. So we have to jump over 8, so 1 plus 8 is going to be 9, so we're going to be finishing up here. Okay? So that middle point, this one here, that's always in the middle in between your period. That's always halfway through your period. So that means, so here's 1, here's 9, and halfway in between would be exactly 1, 2, 3, 4, right here. Okay, and then we know we have to go up and then down, alrighty, and how far do we go up? That's given by our amplitude, which is 3, so halfway in between these points, the 1 and the 5, which is 3, we have to go up to 3, and halfway in between 5 and 9, we have to go down to -3, okay? So we have that, and we can just connect it in a nice smooth curve here, okay? So we have something that looks like this. And we can't forget, we can just continue on either direction. It's important to kind of like draw in this other stuff as well, so the professor knows that you know that the sine graph and cosine graph aren't just like one-time things, and they just continue on in both directions. Okay? So this is what it looks like, this function over here that we were given. Alrighty, so now one final note. Here's another kind of transformation that we could have. Don't worry, this isn't very long at all. Basically, if you have a negative sign in front of your sine or cosine, this is what you do. This just means a vertical flip. Just flip all of your points vertically. So what does that mean? That means that if we have our normal sine graph, okay, so here's normal sine graph. It goes like this, right? From 0 to 2 pi. But instead, if you had negative sine theta, or something like that, let me just draw a little theta there, this is what it would look like. Instead of you starting to go up in that direction, you would actually start going down and then go up. Okay, it just flips. All of your values just flip across the x-axis. That's a vertical reflection. Okay, and let's say we had cosine theta. Normally that looks like this. We just start up, go down, and come up. Okay, but now a negative cosine theta graph would actually start on the other side, go up, and then come down. Okay, so it just flips across the x-axis there. Okay. Alrighty, so that wraps up our concepts video on sinusoidal graphs. I hope that helps, and good luck on your homework.